to eat. And go. Okay, ready to start now. Make a lot of social traffic, generate a lot of traffic. Okay, ready? Okay, phone is okay, there. And also buy a lot of books. CQRS. CQRS is an acronym for something that means all and nothing. What I'm going to show, to present now is essentially how, in which way it represents a more effective way for writing the same applications that we write today. So in a way, it's nothing ridiculously new. It's nothing dramatically new, but it's something that can help us doing complicated things in an easier way, but also in a better and more efficient way, things we do normally. CQRS for the common applications can be a subtitle to this particular talk. So CQRS is an acronym in much the same way these others are acronyms. So I assume that, well, CQRS, was a guy who asked me this morning, yes, but what is CQRS? And I would say, what is G2G2BT or AGKWE? They have a meaning, however. They mean too good to be true. Or they mean, and God knows what else. And the other one means keep up the good work. And the other one means what the hell is next? And this one? But you can hardly believe, but this one too has a meaning. And the meaning is, if I tell you what it means, will you buy me a drink? Okay, so I cannot tell you what it means, but I can tell you what CQRS actually means. And it means specifically command and query responsibility segregation. So, in which way CQRS is important? Because we essentially have one comprehensive software model for a business domain. If you attended the keynote yesterday, I spent a bit of time emphasizing the importance, just for the money, for the financials of any software project, that we understand the business domain, the mechanics of the business domain. But when we approach this task, we see, at least initially, just one comprehensive model for the business domain. And what CQRS suggests we do is that we simply split one model, comprehensive, in two models. One into, let's say, blocks of code. One that takes care of comments, and the other one that takes care exclusively of queries. Because an old concept in software engineering that dates back to probably the 80s, so when I was looking for girls and only interested in teenager activities in the 80s, so there was a guy, was called Bertrand Meyer, who already formalized the core concepts that we today have renamed CQRS. He called something like CQS, common query separation. We just added the responsibility level. We want to just separate responsibilities because we recognize that in software there are only two things we can do. We can run a command, and the command is characterized by two aspects. It alters the state of the system, and it doesn't return data. It just accepts basic data like I've been successful or not. Just accept X. I've done it or I failed. Beyond that, it doesn't return readable and consumable information, but it does alter the state of the system. Conversely, the query module, the query block, the query pipeline, all it does is returning a consumable data, but it doesn't alter the state of the system. Pretty fairly obvious. Now, when we do domain analysis, we understand the ubiquitous language, we figure out bounded contexts that form our software model. We have the next problem we have is, okay, now what about implementation? How to design a single model that works the way we expect, that renders carefully and faithfully aspects of the business domain. Look, I said a single model, but when I say single model here now, I mean single model for each of the bounded contexts we have already identified. So I'm not talking about the whole entire application, a single model for that, but for all of the subdomains we identified that we called bounded context, if we use a DDD terminology, but it's just for all the subdomains, the subsystems, we have a model that is single in the sense that it takes care of commands and queries, all possible operations for that context. How can we do that effectively? And we know that there is a theory and there is practice. In theory, it says, oh yeah, if you apply all of the patterns out there that gurus have created over the past decades, that's a theory and it's like straight like this. You can proceed from start to end in a straight way. The reality shows that roads are not always straight and they may even have a lot of construction along the way. But the complexity we face in software, what we call software complex. Why? Okay, we call it complex because actually it proves complex, but why? Let's say that in a way we have at some point a relevant data to deal with, and this data for the most part, today at least, is stored into tables, relational tables. On top of this relevant data, we likely have relevant tasks. So what I'm trying to do now is just trying to abstracting as much as possible the mechanics of software development, just to go to the root and understand where the complexity comes from and what we can do to effectively handle that. So relevant data and relevant tasks and some interconnections. And it's the interconnections that generate the complexity and our ability to handle and represent effectively those interconnections. More, when we model a business in software, the difficulty is just in understanding the arrows between relevant data and relevant tasks, and those arrows grow and became more convoluted over time, and also as we understand more and more of the business domain itself. The point of my talk of yesterday, what I call UX-driven design, is that if we can reach a point before starting putting a lot of effort, billable effort in software development, if we could understand as much as possible of the arrows between relevant data and relevant tasks, well, we have a task assigned that doesn't change, whose size, whose complexity remains relatively fixed. Once we reach an end, once we have done all about it, we have that reasonable certainty that it's okay, that nothing else can come. So you are, in a way, programming in a worst case scenario. You know at the worst what you have to do, and once you have done that, you're okay. You're pretty much done. Instead, when you have relevant data, relevant tasks, about some of the arrows, and your approximation with this schema and the real world is not that good, at some point you figure out that there are even more relevant tasks and even more arrows, and this is called a mess, a total disaster. The canonical architecture we know, this is also, it's called the layered architecture, and is one of the it's the canonical architecture that domain-driven design pushes out and recommends. But even beyond domain-driven design and the name layered architecture that has been used to describe this one here, it's nothing, nothing fancy, nothing special. It's just yet another revisitation, just a revision of the classic multi-tier, three-tier, multi-layer architecture. Business, presentation, business, data. Well, we have 4 layers: presentation, application, domain, infrastructure. Infrastructure is essentially a name that encompasses all the persistence tasks and even more. Application and domain layer are just a split of what we would have otherwise called the business layer. Because in the business layer there are many gray areas. There are 50 shades of gray areas, and it's never completely clear, a given task, if it's presentation or it's data or it's something in the middle. With the application and domain layer, we operate a clarification. We say, look, the business logic is made of 2 parts. One that is application specific, and because of that, it strictly depends on the requirements of the presentation. The other part is domain specific. It's called domain logic, and that is invariant to the logic of the application, to the tasks that the application has to implement. So in this case, it doesn't depend on the use cases, the ways that users have to interact with the system defined in the presentation. So it's reusable in a way. The classical example to show, to illustrate why it's good to have application layer and domain layer is, think of a mobile application that goes side by side with a website. They are 2 different applications. One is a website, one is a mobile app. And it's reasonable to expect that the ways that users have to interact with the system through both applications can be different. Maybe on a mobile application you have additional features and you lack some of the features you have on the website, and vice versa. So they are 2 different presentation layers, and subsequently they have different use cases. Because of the different use cases, you may even have 2 separated application layers for the mobile app and the website. It could even be the same, but it's acceptable that they are different if splitting makes it easier. If splitting makes it easier. Nice. Note to self, remember that. The domain layer is the part instead of the system that both mobile apps and websites use together, share together. The union of application and domain makes the business logic. And in the canonical layered architecture, we have just the 4 layers, and every task goes straight from presentation down to infrastructure and back for reading. What CQRS suggests we do is something slightly different. We still have a presentation layer. We still have infrastructure layer. We have then separated an area for commands, an area for queries, and the command part of the system here has an application layer, has a domain layer, and goes to the infrastructure. But the arrow just goes down. So the idea is, from the presentation, the user pushes a button to trigger whatever task. The task is orchestrated at the application layer level. It's performed, going through business rules in the domain layer, and reaches the infrastructure where the results are saved persistently to whatever store we use. SQL Server, Oracle, relationals, or maybe document databases, Raven, Mongo, whatever. That's it. The command executes, alters the state of the system, and that's it. What if we want to read back the results? We don't want to read back the results of a given operation. That's the point. That's the difference. What we want to do is a system that has actions and then read actions just to read the current state of the system. So in this scenario, we are led to think that we run an action, go through a task, and then want to see back the results of the task. That's why we need to concatenate commands and queries. In this scenario, if we treat commands and queries as separate entities, we run a command, and then at some point, maybe instantaneously, we just read, okay, what's the current state of the system now? So, imagine something like a web page, Ajax-based, where you have buttons, the user clicks buttons, the buttons triggers a command, the command modifies the system, and then imagine you have some sort of, I don't know, long polling that periodically refreshes the UI, making calls to the server, getting JSON and refreshing the UI. But this approach goes well together with things like reactive interfaces, in which there is a command, there is something that happens on the server, and then there is some notification pushed to the user interface for the interface to refresh. And when the interface refreshes, it just runs queries for, okay, what is the current state of the system? I mean, I'm on page A, give me the data for page A, and page A just refreshes. But commands and queries run separately. In terms of architecture, the immediate benefit we gain from this is that we can have a separate class libraries to implement the commands and to implement queries. This means that at some point we could even consider putting this part of the system and this part of the system on distinct web servers and optimize them separately, with the certainty, with the guarantee that whatever we do to, say, make the query faster, maybe adding caching layers on the front of the website, doesn't affect in any way the execution of commands, and vice versa. So if we have a system with lots of writes and lots of records being created because of these writes, at some point we may even face the problem of performance, because in a relational database, the more you write, the more you stress indexes, and if the numbers of writes and subsequently records is significantly high, you may even start observing some performance leaks, which is not good. And this is just the scenario that documented databases, with their eventual consistency, so you write, at some point data will be in sync with what you read, addresses, because it makes easier and fast, incredibly fast to just write, as long as you don't expect to be able to read what you have just written instantaneously. Just wait, allow for a few milliseconds, okay, of latency until what you have just written is immediately readable through the indexes layers that the persistent store has. It means that in a system like this, architected following the CQRS principles, you can have the command stack that ends up writing on a document database, and you can read it back, maybe from another database, kept in sync by some sort of magic on the server. So you read and write in an optimized manner from different databases, kept in sync in some way, and you have all the tools you need to optimize both parts of the system following to the business needs. Over the years, we faced a lot of complexity several times, and we always failed, I think, to understand the mechanics of this complexity. And I would say that this expression here, the order of magnitude, the order of complexity of a system in which we don't separate commands and queries, is some sort of the product, even the Cartesian product, if you want to be cool, of the complexity of commands and queries. In CQRS is the plane union, sum of both. So sum versus multiplication. In CQRS there are benefits and side effects. Honestly, I don't think there are downsides. If not, maybe resistant to change. But it's faint resistant. The benefits are essentially design that becomes far simpler. And there is at the same time, because of the separation, a potential for scalability that we can express, we can obtain without significantly modifying the code. So we need to scale the system more. Okay, if it's already architected following CQRS, it is simpler because at the worst, it means just put the query, just duplicate the system, the front end of the system and the business and the query part on a separate server, and put all varnish, NGX, all caching layers in front of that. On the other part, you optimize the command query, just put the system as is on the part of the system as is on an Azure web role, and spawn new instances of that web role. The problem the practical problem that remains is, okay, what about the user interface? The user interface belongs to the query part, the server where is the query part, and then from probably the only aspect you need to fix is how from the user interface you call to another server where there is a command stack implemented. But with an Ajax rich JavaScript interface, this comes even easier to do. So, but anyway, these are the details of how we do this can be discussed on a per project basis, but the fundamental issue, architecturally speaking, is the potential for scalability that results from the ability to treat the system in two distinct parts, each with its own life. Stacks are easier to maintain and evolve and can be optimized separately. Business domain is unique. After the DDD analysis, we have split the otherwise unique business domain in multiple bounded contexts, and after the CQRS design, we have split each of the bounded contexts in two parts, commands and queries. So the end is that what was one big project to handle has become 6 smaller pieces. This is simplification of the design and whatever else, potential for scalability, because each of this is a separate entity that can be optimized and deployed in the way that helps more. There are three flavors of CQRS, because, okay, CQRS, what I said so far is just abstraction, just abstracted ideas, general ideas. Concretely, there are at least three types of architectures. I call regular, premium, and deluxe. The regular architecture is a plain stupid system in which you use anything as simple as a transaction script pattern for implementing the business logic. A transaction script is just a sequential procedure for each task. Each button that generates a task, I implement the task start to finish. Reading when I need to read from the database and writing when I need to write to the database, but with the purpose of executing the command. And just like, I mean, the type of programming of the 90s when I started. Okay, start to finish, start to finish, start to finish for each task. That's the transaction script. It's easy to understand, easy to implement, with the potential for some redundancy and code duplication, but that can be handled with programming tricks and routines and structured programming. I also expect that in a regular scenario, reads and writes share the same database. Premium, it's more sophisticated kind of thing in which on the command stack you have a domain model, you have a lot of objects, you have aggregates, you have objects instead of reading and writing on plain database tables. You do what typically domain-driven design means. Okay, an object model following guidelines and express business rules and workflows as much as possible within object-oriented classes. In this case, you can have that the command stack has a database where it saves the state of the system, and then you can have another parallel database where you write redundantly data in a way that is ready for reading, for the user interface. Maybe if you have different types of users, because your system has roles, has a strict security constraints, you can even save on a per user, per classes of user, per role basis, data ready for the UI, so that when it comes to reading, you have just to run the query directly against the DB with no layers in the middle and just bring data up to the UI for the fastest possible response for users. And finally, deluxe is when you have an event-driven architecture, and essentially you use events to make the implementation, to implement the business logic in a kind of reactive way, so that you express the steps of each workflow has a reaction to a previously happened, occurred event. I start the creation of an order. That's the command. Create order is the command that is pushed from the UI. The creation of an order starts a workflow. The workflow is a class that you code, and this class, instead of having step 1, step 2, step 3, step 4, if step 3 fails, then step 5, and so forth, the classic flow chart of a workflow, instead of having that written in C# or whatever language, one instruction after the next, with every control in code, is each step is a command pushed to a sort of a bus, and then there is an handler that captures that event and does its own small piece of code. So by changing the order of events or by adding more handlers, you can modify the final effect of the execution of a task in a way that is extremely simpler to handle. So you are not losing anything, you are gaining a lot more expressivity. Okay, apparently I am done. Done? 1 minute? Well, 1 minute? Okay, there are 3 more slides, but anyway, 3 more slides. Essentially we're graphically demonstrating the three types of architecture. This is the regular CQRS with transaction script presentation, application, various transaction scripts for each command, and on the way back there is optionally an application layer or directly the DAL that returns data to the presentation. Premium is when presentation, application, domain for the command stack, something that keeps in sync the two databases, and from these databases optimized for reading, data goes up to the presentation. And finally, the deluxe is when you have the application layer that pushes events on a bus, and the bus knows, because you register with the bus at the startup, a bunch of components called, well, these are just jargon terms, sagas and handlers. So essentially instances of processes, of workflows. Okay? So the saga is the class you write, or the handler is the class you write to start a process. So it's the orchestrator of a bunch of things. So the saga is responsible for starting a process following a UI call, and then it, does some of the work, and then I've done this, and other components, handlers, or other sagas can take up from there, perform their own task up until the original saga ends, which means that the workflow has terminated. The bus is central here because it can be just an in-memory bus, so that every operation starts and ends in a matter of milliseconds, or the bus can be able to persist the state or queue requests, so that every saga can be implemented around processes that may take days or long-running, the classic long-running processes, depending on the bus you write. And you can write yourself an in-memory bus, but if you want a bus that supports queues and supports persistence, you probably need to get some existing tool, and service bus, for example, is one of the most popular. Each saga and each handler is able to go through the set of business rules and write. At the same time, the bus may have the need of persisting events, so what has happened, so that you have a log of the steps performed through the system, and you can replay those events optionally to enable what-if scenarios, and also to rebuild from the events the state of the system. You can have the state of the system entirely rebuilt from events, or you can have events here as an history, an additional history, and have written here the state of objects. There are so many different flavors of architecture, even in the context of a deluxe architecture. The state is optionally saved, ready for reads on another database, which is served by the query stack. At the very end of the day, CQRS is not a philosophy or methodology, it's just about writing code, and the best selling point is that it looks like common sense and just a smarter way of doing the same things. It's the best way I know, and I recommend for code that works well in this crazy world. Thank you for your time.
Is a technologist from Omsk. Is it possible to return where we can compare the canonical architecture and CQRS?
The slide you mean?
The slide, yeah.
This is the annoying part of animations.
Oh yeah, okay. Even not considering the fact about that we were trying to hide the infrastructure layer from the presentation layer in terms of security, well, just consider the fact that, okay, let's do like this and divide the commands and queries each from each other. And if there is one session of user, it's okay. What if we have a lot of sessions and the concurrent work? I mean, I think that there are the same problems which every relational database management system solves. Exactly, I mean, data read or phantom reading or loss of change or something like this. I mean that just imagine that some user writes something into the database, and some of them trying to get something from this exact database in the same time. What if we just lost some change? I drive at the fact that we need to synchronize these parts. I think it's just complexity, isn't it?
It depends. What you have said makes sense. I mean, in a system that is highly concurrent, in which many users write and a great number of users try to read at the same time, there is no clear rule on what is the best. It depends on the scenario, it depends on the application. Because if you don't have problems in writing and supporting this, it's a database that doesn't work for you. You have just one database, you write it to the database and you read, but it's the classic lock and unlock issue. If I can write, if I can read. So it's nothing different, okay, from what you do today. So whether you use this architecture or this one, but no, I mean, this is the same. If you use the same database, there's no difference at all. I mean,
I mean that in the canonical layer architecture, domain layer is a controller, and I control.
No, domain layer is not a control. No, there's no controller. Domain layer is simply, I mean, it can be whatever you want, but it can be whatever you want. But let's say that I would call the controller probably in the application layer that decides, and the domain layer is just, it's mostly for the domain layer. You typically use the domain layer with as the point that contains business rules and workflows. Typically, you use that only to go down. I would expect most from possibly an application layer, or if not right in the application layer, to have controls on which can read what. So you simply disable pieces of the UI, or you just don't offer commands to go down, or anyway, you use the controller at the application layer. Okay, imagine that in this slide, you have an optional, you also have the application layer here, and that remains your controller. It's missing in this slide, but there is a dashed application block in the further slides in the presentation where I try to detail a lot more the typical flavor scenario. So if you need to control it some way who reads what, and you want to take control of that, and don't want that to be just disabling controls in the UI, okay, you can have an application layer. The point here, the fundamental point is that you don't need at all a domain layer with business rules when you're trying to read. So if the implementation of the domain layer, whatever it is, in object-oriented via domain model pattern or other patterns, if the part of that has to do with commands is one thing, the part of that has to do with reads, which has nothing to do because you just read, and maybe the only filter is who reads what, so security filters that you can have in the application layer, so you just don't need, and your read from the data is essentially plain, stupid, silly TSQL queries. No?
Я прошу прощения, у нас осталось время только на один вопрос, и после этого мы сможем отпустить всех на обед.
Hi Dino, thank you for excellent speech. My name is Alexei, I'm from Parallels, and my question about this slide too. If you have two different presentation layers or more different presentation layers, we have different application layers, and we share domain layers between these presentation applications. It's okay. But what about data access and DTO module? Shall we share this module too, or it is supposed that we have to write different DTO modules for different applications?
DTO is data transfer object, so it's just a union of properties that carry data for the purpose of the presentation. So I would say yes. It's a different presentation is different, potentially different application layer because different use cases or different data to display, potentially different DTOs, different groups of DTOs, yes.
So it means that DTO module have to be closer to presentation layer, not to infrastructure layer, yes?
Absolutely, presentation, yes.
Thank you.
Все, заканчиваем.
Да, друзья, у нас, к сожалению, кончилось время. Скажем спасибо, Дина.
Thank you.
Esposito.